So example 1 asks us to add these two polynomials, and then it also asks what's the degree of the sum. We'll worry about that after we add them. All right, so it might say add every single time when you're adding or subtracting, so be careful. Algebra books are weird that way sometimes. Algebraic addition sometimes involves adding a negative, so you might see a minus sign, they might say add. I chose to use the word subtract on the subtraction problem. Anyway. But you can see we have a polynomial 6x cubed plus 4x plus x squared minus 7 being added to the polynomial 2x cubed minus 8x squared plus 3. All right, so first thing I want to do is I want to rewrite this thing with no parentheses. It is an addition problem, so all I have to do to make the parentheses go away is distribute whatever's in front through the parentheses. All right, if there's nothing in front, there's no need for the parentheses. So I'll write the first one down. Oh, and one other thing to consider. Maybe. There we go. We have 6x cubed, we have 4x, we have x squared, we have minus 7. When I'm looking at the order of terms, a descending order is the best, and all that means is looking at the powers, they go down one at a time. So the third power, followed by the second, followed by the first, followed by the constant. That's a better order to put it in. So I'm going to rewrite this first polynomial here as positive 6x cubed, positive x squared, negative 4x, positive 4x, and then negative 7. Okay. I just swapped these two terms' positions in the expression. Okay. Notice there is no equal sign in this problem. I'm not moving things across an equal sign, so signs aren't changing. I'm just rearranging things. This belongs in front of that, so I put it in front. They both stayed the same sign, positive x squared, positive 4x. Again, there's nothing in front of the parentheses to create any sign changes, so the signs are what they should be in the expression. We're adding to that polynomial 2x cubed, negative 8x squared, and positive 3. Now what I personally do for an addition problem is I write underneath the first one the second one. So I would put them in columns, and the columns I'm going to do in like term fashion. So when it says plus 2x cubed, because that's a positive and that's positive, I'm going to put plus 2x cubed right underneath 6x cubed. I want like terms to line up. Then I have plus negative 8x, which is negative 8x squared, plus negative 8x squared is going to be minus 8x squared. Then I got plus positive 3, which is plus 3 underneath the negative 7.
Is it illegal to put like plus 0x?
You can put plus 0x if you want to. It's not necessary. It's going to have the same effect. I've got nothing there, so nothing's going to happen. You got 0x, which is still nothing. So you can put a 0x if something's missing like that. That's fine.
It just would help, like.
Yeah, if it makes you feel better to put that, you sure can. Absolutely. So you can see here that I've got my first one written down in descending order. I've got my like terms lined up in each column. And like Alyssa said, if you want to put plus 0x there, you sure can. I'm not going to. I usually don't. So I'm going to add straight down then, the like terms. And to add terms, we're going to add coefficients. So this is 6 plus 2 makes 8. And then it's going to be 8x cubed. Notice the power didn't change. Okay, powers do not change when you add or subtract. They only change when you multiply. Okay, so 6 plus 2, both positive, adds to make 8. X cubed stays x cubed. The second one, and this is plus x squared. You might want to put a 1 there to remind yourself there's a 1 in front of it, because again, we're adding coefficients. Positive 1 and negative 8, those signs are different, so I subtract. I'm going to get 7x squared. 8's bigger than 1, so it's negative. When there is no like terms, when it's just a term, it just goes straight down, nothing happens to it. So again, if you put plus 0x, 4 plus 0 is still 4. So again, the 0x is fine, but again, just if you got nothing added to it, it just comes down, part of the answer. And then finally we have negative 7 plus 3. Those are opposite signed terms, so we subtract and get 4. 7 is bigger than 3, so it's negative. And that's the answer. That's all there is to adding polynomials.
So like when you did those arrows to the
Yep.
Up top.
I'm
the red?
distributing, yes. So it's plus positive 2, plus negative 8, plus positive 3. So it just generated those signs there. If there happened to be a number there, is that what you're getting at?
Well, like, does it do anything, those arrows, like 17?
No, not in that case, but in the next problem, you're gonna see it does do something. So, it's good to create a habit. Sometimes something happens, sometimes it doesn't. But just go ahead and assume that every time something happens, and if nothing happens, no big deal.
So say it was like a negative there, it would make the 8 positive.
Exactly, so on the next problem down,
Okay.
you're gonna see that's what's gonna happen. So, again, just assume something's gonna happen every time, and sometimes it doesn't, and you still get the right answer. Yes, Cody?
Does the degree of the sum mean anything, or
Yes.
is that?
Well, I'm not, that's the answer to the add
Oh, okay.
problem part. Now, we haven't done the second part. So, now we still have to find the degree of the sum. What is the degree of the sum? Okay, a little vocabulary for you. Degree of a term, let's start there. Degree of a term is the sum of the exponents of the variables. Terms are separated by pluses and minuses. So like in this problem, 8x cubed is a term, 7x squared is a term, 4x is a term, 4 is a term. So each term, something plus or minus something plus or minus something. Each plus or minus separates the terms. Term 1, term 2, term 3, term 4. Okay. It's the sum of the exponents of its variables. If it's only got a single variable, it's the exponents of the variable. So the degree of this term is 3. The degree of this term is 2. The degree of this term is 1. The degree of this term is 0.
And since the sign at the beginning is subtraction sign, would we subtract them or does it matter?
What are we subtracting?
Or do we add all the degrees?
No.
No, because
No,
the exponent.
Again, whatever the power is the degree. So 8x cubed, the degree is 3. 7x squared, the power is 2, so it's 2. X to the first, the power is 1, so it's 1. This has no x, so its degree is 0. That's all degree is. So you find all the variables, all the letters in the term, add up the powers, and that's what its degree is. So the degree of each individual term here is 3, 2, 1, and 0. All right? That's the degree of a term. You need to know that to find the degree of the polynomial. Because it says find the degree of the sum. This is not the degree of the sum. This is the degree of each individual term in the polynomial, the sum. All right? Degree of a polynomial is the highest degree of any of its terms. So once you establish each individual term's degree, the degree of this is 3, the degree of this is 2, the degree of this is 1, the degree of this is 0. Whatever the highest number is in that list, that's the degree of the polynomial. So the degree of the sum is 3. So-
How to get that again? You just said the
So,
highest one?
yeah, once you find each individual one, 3, 2, 1, and 0, whatever the highest number is, that's the answer. So you're looking for the degree. So I wouldn't even have, Zach, if I was doing this problem, I wouldn't even have this written on my paper. I would mentally find each degree, 3, 2, 1, 0, 3 is the biggest, the degree is 3. But again, that's the mathematical process. You know each term's degree, whatever the highest one is the
Do you
answer.
want us to write degree sum is 3 or? can we
Well,
put
I wrote it that way because I already have a degree written here, so just to distinguish. So the answer, if you're just writing the degree of the polynomial, you can say degree equals 3, that's fine.
Okay.
And don't get too hung up on degree. I'm throwing this in here because I saw the word thrown out in the instruction in the chapter. It might show up in a problem or two in the homework. I wanted you to know what it was in case it did. It's not a major importance at this point. Being able to add polynomials is the most important part of the lesson. If you understood the first part, you're fine. If you don't quite understand degree, again, it's going to just show up on your homework. I'm not going to throw that on a test. Okay? I'm not too concerned about degree yet. When it comes to be important in your life, then we'll spend more time focusing on it. But again, know how to do it, be able to do it, but don't get all bent out of shape if you're not quite understanding it.